Hey everyone, what's up and welcome back to my channel. Question: what does a panda ghost eat for dinner? Bamboo. Okay, so this is the ghost badge that I made for this upcoming Halloween. It's a simple 555 timer IC based biflasher setup which is powered by a CR2032 cell. The goal here was to make a small THT component based soldering kit that you guys can use to challenge yourself for doing soldering. Apart from this premise, it's a small PCB badge that looks like a bedsheet ghost with two eyes that are constantly flashing. Its construction is also relatively simple as we only have to put few THT components in their assigned place and our badge will be completed. No coding is required whatsoever. This setup can be easily made with a microcontroller, but to save cost and stuff, I choose this OG setup of all time, the 555 timer IC. In this video, I will be showing you guys how I designed this badge and its assembly process. So without wasting any more time, let's get started. These are the components that I have used in this build. 555 timer IC, custom PCB, 3mm LEDs, micro USB port, the THT1, not the SMD version, 1 UF capacitor, coin cell holder, 68 kilo ohms quarter watt resistance, 1 kilo ohms quarter watt resistance, and an SR206 diode. The 555 timer IC is a clock generator, which means it's a circuit that may be connected to a stable or a monostable multivibrator. In easy words, it's a monolithic timing circuit that can produce timing pulses around 50% or 100% duty cycle. Here's the schematic that I've made for this PCB. I made the general biflasher setup with the 555 timer IC. I also used this USB portion so I could use a 5V charger to power this board directly without relying on the coin cell. After finalizing the schematic, I exported its netlist and converted it into a PCB design. The PCB designing process includes adding all the stuff inside the bedsheet ghost outline. I added the BMP image in the PCB design to the sill screen top layer. This BMP image contains all the important graphics or shape of this ghost. After placing all the components, I then connected their tracks together, and that was pretty much the design process of this PCB badge. Also, I used THT components in this project. No SMD stuff has been used. Why THT components? Why not use SMD components? For making this project easy to assemble, I eliminated all the SMD components that I usually use for my badge project. Like in this flux capacitor badge, I have used lot of SMD components including 4 MOSFET ICs and many LEDs. THT components are easy to solder and that's why I use them. After finalizing the PCB, I check it one last time and then I exported its Gerber data. I uploaded the Gerber file of this project on PCBWay's code page. For this ghost theme badge, I went with the white solder mask and black cell screen. After placing the order, I received the PCBs in a week and the PCB quality was pretty great. The shape is completely random, so it's pretty hard to make, but they did an awesome job of making this PCB with no error whatsoever. PCBWay, you guys rock. Check out PCBWay for getting great PCB service at a less cost. Because this PCB doesn't have any SMD components, we don't have to do any fancy SMD process in this project. I generally make PCBs with SMD components that require a solder paste process and other things, but we don't have to do that with THT components. We just do two things for the assembly process of this THT circuit. We first add THT components to their assigned place according to the given schematic. Then we solder each component and then cut their excess leg with a wire cutter, and our PCB is completed. I didn't have the THT switch at the moment, so I added a CON2 header pin to the switch pads and then use a jumper connector to turn on and off this circuit by manually removing the CON2 jumper connector. It's a temporary thing and I will remove this when the switch will arrive. As for the power source of this badge, I added a coin cell holder so I could power it with the generic CR2032 cell. But I have also added a USB port to this setup so I can power it up with a 5V 1A charger. Both of these sources work, but the coin cell is more practical as you want to wear it with an ID card strap or add this badge to your keychain. You could just power it up with a coin cell and it will look pretty sick. But a charger won't work with the wearable stuff. Here's the result of this small build. LEDs are flashing and everything is working as it should be, which is great. Also, here's a mistake that I did. I forgot to add a connection between pin 4 and pin 8. Because of this, when we power this circuit for the first time, only one LED will blink. I added a jumper between pin 8 and pin 4 externally and it worked. In the next version, I will correct this mistake in the PCB, but this is it for now. Hit the subscribe button if this video was helpful and fun. Also, do check out PCB Way for getting PCBs at an economic price and great quality. Stay safe and I'll be back with another project soon. Peace out.